Okay, I think I'm recording. Hopefully I am. Otherwise, I'll just have to do it again, right? A few of you have asked for some examples on rational expressions. And if you'll remember, a rational number is simply any number that can be written as a quotient of two numbers, where q of x does not equal 0, because we can't have 0 in the denominator simply because that gives us an undefined boundary. Later on in calculus you'll learn why that is, but for now this is the definition of a rational number. Now, a rational expression, on the other hand, is simply things that we've been working with up to this point. X plus 3. This can be written as a fraction, x plus 3 over 1. Or perhaps we have something a little more complex, x minus 4 over p plus r. Something along those lines. Both of these are actual rational expressions, assuming that p and r are not 0. So with that in mind, let's continue on here. And I'm writing uphill again for some odd reason. There we go. Just trying out a simple a line there. And let's start with just a few basic steps back from a couple of chapters ago, where we have x squared times x plus 1 over x times x plus 1. Now, if you'll recall from the fundamental properties that we can actually quote-unquote cancel these things out. Now, you'll also recall from the earlier chapters that when we had these types of things happen, let me grab a different color here, with the exponents being different, that we would subtract them in the case of division. So x squared minus 1 equals x to the 1, or x. So this is actually our answer that we would need to plug back in, but since everything is 1, there is no sense in doing that. So your final answer here would be x. Let me grab the black here so I can break the screen up just a little bit. So let's say we have something a little bit more difficult, not too insane, and x minus 3 over, I'm still writing uphill, I cannot stop this, x plus 5 over x plus 4. Well, again, we'll look at the entire fraction in itself, and we'll see that we have an x plus 4 that we can cancel out, which becomes 1 over 1. So we're left with, I need to go back to my color here, x minus 3 over x plus 5. The parentheses are unnecessary, but I'm just leaving them there just for illustration purposes. So let's try another one. As soon as I find out where my cursor is, I can go down a little bit more. And let me draw a line here so we can see what I'm doing. Let's say we have something like 4x times x plus 3 over 8x squared times x minus 3. Now, we need to look and see what we have going here. And we have two even numbers, 4 and 8. And we also have two x's with two different powers, which we can do things with. The x plus 3, x minus 3, not much we can do with that guy, so we'll just have to leave him alone for now. And where did my cursor go? Oh, there it is. So equals, and we would know that 4 and 8 reduces down to 1/2, so I'm just going to leave the 1 out. And we know that from what we had done earlier, that we're dividing x to the 1 by x to the 2, or x squared, which is going to give us x to the negative 1, or an x 1 over x, which would put this here. And then of course we have our x plus 3, which we can't do anything about, and our x minus 3, which is kind of coming along for the ride. And this is as far as you could actually get this thing to go down before you would perform any actions on it. There are a few rules and things regarding not points, but exponents that will give you points on the line or number line where Windows has detected your computer's performance is slow. Oh, I'm thankful for that, Windows. Please stop interrupting my video. So anyway, now, oops, there we go. So let's try another one. Again, we're just kind of reviewing, and this is the first part of the section of homework. And we have 3x plus 7 over 3. And we're looking at this thing and looking at this thing. Before we would call this thing prime, but in this case there's nothing that we can do to it, so we just leave it alone. Therefore, this is our answer. That last line did not draw as well as I had planned. That one's a little better. Okay, so let's move on just a little bit here. Find my downward arrow. Oh, blue. Let's try blue. And let's try something just a bit more difficult. Don't want to scare everyone off. 5s minus 25 over s squared minus 25. A lot of people will ask why I don't make my s's this way. And quite honestly, if you look at my s and my 5's here, that's the exact reason why I don't. So I use the cursive S, and it helps me to at least understand what's going on. But anyway, in the top here, we have 5s minus 25. And we can see that we can take a 5 out of this entire thing, leaving us with this. And we see that the bottom is actually a difference of squares. So we can go s plus 5 and s minus 5. Now, going back to our fundamental properties, we can reduce this by crossing these out. And that gives us 5 over s plus 5. Now I'm writing downhill. What in the world? This is the greatest thing since sliced bread. I cannot get used to this tablet. One day I will. Oh, wow, that's the straightest line I've drawn to date until I'll get excited and jump for joy and roast marshmallows and sing Kumbaya. So anyway, one more example for this, and I'm sure you get the idea by now. Let's say we have something like 6m plus 18 over, and here I go back uphill, 7m plus 21. Now, again, looking at these, well, we can factor a 6 out of here on the top and give us m plus 3. And on the bottom, we can factor 7 out, giving us m plus 3. Well, that's great, because now we can actually simplify this entire fraction by these two canceling one another out, creating 1 over 1, and giving us, wrong color, Nathan, giving us our answer of 6 over 7. Now, again, this is just a very basic rundown of rational expressions. In case you're wondering what that noise is, it's the heat or air conditioning. I'm not sure what the heater's on. I should probably reach up there and turn that off, but oh well, it's okay. So let me go down here, and I'm going to start this section of what I like to call dirty algebra. And this is the algebra that you really don't learn until way later in like calculus, Calc 1. And differential calculus, where you really need to get these expressions to actually equal something. And that's the underlying basis for all of this stuff that we've done before. But I'm going to show you just a simple way of really, what in the Lord's name is going on here? Alright, well, we can just keep changing it on me. What's that? Okay. So anyway, my computer's being strange. It's great. We'll just ignore it and pretend that everything's okay. But if we were looking at some expression in arithmetic, basic arithmetic. Let's say 3/5 plus 7/8. Now, oftentimes you'll hear people say, well, you can find the lowest common denominator here and here, and you'll get a number, and you can use it and all of these other cool things. Well, that's true. However, when you start doing these with nothing but letters and cool things of that nature, well, we can't really get a number. So what's an easy way of doing this? And the answer, again, is this dirty algebra, as I call it. So 5 times 8 will go on the bottom as the denominator. And on the top here, we will have 3 times 8 because of the way of getting the common denominator. It's just kind of a shortcut of remembering. And then we bring our sign over, 7 times 5, over, again, 5 times 8. We'll go down here, 24 over 40, plus 35 over 40, which then gives us 59 over 40. Now, this would be our answer to this, but what about this guy? I mean, this is a train wreck waiting to happen, or so you would think. If we follow the same paradigm, we would have the denominator as BD. I should write this longer. And we're actually going to have AD plus BC on top. Now, if this were, say, A over B minus C over D, no problem. AD minus BC all over BD. This is the thing that I like to use in my classes simply because it's very easy and it teaches you a lot better than some textbooks will actually do. There are a few very good ones that will show you some other ways of dealing with these, but for the purposes of this class, this is enough to get us going. So let me draw a line, find my cursor, and go down a little bit more. And this video is going to be a bit longer than the others simply because we have a lot more to cover, but if we're looking at something like 5 over 2p plus 3 over 8p. Again, if we follow the paradigm up above, we have 16p squared in the denominator, and 5 times 8, which is 40, and we'll just bring the p along for a ride, plus 3 times 2 is 6p over, again, 16p squared. And if you look, these actually reduce to these guys here. Just a little thing that I like to point out. 46p over 16p squared. I almost did the error of adding 16 and 16. Oh well. So we see that this reduces because we have a p and a p. So 23, the p will disappear. This will become 8p because if you remember, p to the 1 minus 2 equals p to the negative 1, which equals 1 over p, which is this guy right here. Okay? Very straightforward, very little mess and fuss. There are a couple of ways to do some other things that we'll be getting into, which is complex fractions. Just for a couple of examples on these. This one is a common thing that I've seen students struggle with. Something like 7x over 3x plus 1 minus x minus 2 over 3x plus 1. Now, it's a very common error only to carry this negative sign to this beginning. But since our denominators are the same, we can rewrite this to kind of save ourselves a little bit of headache. And we can distribute that negative 1 through, so we get 7x minus x plus 2 over 3x plus 1. And then, of course, we will simply combine like terms. 6x plus 2 over 3x plus 1, which looks like it's going to have some more fun to do. We can take a 2 out of there, have 3x plus 1 over 3x plus 1. Well, that was quaint. That's an interesting problem. Where in the world is mine? There it is. I keep losing that little dot on my screen. I can't see it because my head's turned sideways while I'm making these videos. And I can't see where my pen is in relation to the dot at the same time. So 2 over 1 equals 2. So here is our final answer. Now, very straightforward process that I like to teach. As soon as I find my cursor again, I'm going to be happy. Alright, another straight line. I'm on a roll today. It's Saturday and I'm drawing straight lines. So anyway, we have something like 1 over q minus 1 minus 1 over q plus 1. Well, this is different than that one, so we can't just flat out go for this and try to be really cool. So let's do the dirty algebra. And I honestly will tell you to leave these things looking like this in the denominator until you are extremely finished with this. Sometimes because these things will usually cancel out in the end. And all I'm doing again is I'm multiplying everything by the dirty algebra paradigm that I've created or previously shown you. Now that we have a common denominator, let me draw a larger line here. Q minus 1, the quantity of Q minus 1 times the quantity of Q plus 1 as the denominator, and we'll have Q plus 1 minus Q minus 1. So that gives us Q plus 1 minus Q plus 1 over Q minus 1, Q plus 1. Let's see, the Q's will go away. That gives us 2 over the quantity of Q minus 1 times the quantity of Q plus 1. Now in my classes and such, this would be an acceptable answer in the end. If someone were to say, well, go ahead and, I want you to go on and finish it out, then you would just simply FOIL the bottom out, giving you Q squared minus 1, because these, of course, are perfect squares, or difference of squares, I'm sorry. And that gives us this guy here on the bottom. Now, yeah, let's not brush to the left, because that's not as cool. So let's move on from that, because quite honestly, it's a very easy concept to grasp once you've practiced it a little bit. It's very easy to see where these things come into play. There I am. So another dirty algebra technique that you've already been exposed to is when you see, fractions divided by fractions, these complex things, and the rules would tell you to look at this in this way and then keep going, but this also implies that A over B is all of this equals A over B times D over C. This comes from the fact that when you actually divide these things, you're ending up with the reciprocal anyway. So that's why they will generally teach you, or professors or teachers will generally teach you, multiply by the reciprocal of this guy, which is simply D over C, this right here. And this is true. This is a dirty algebra technique that you've been taught time and time again. So how does that work? Well, we have AD over BC. Great. Or we can just flip it over and keep going. I have a few examples here. Let's do one. 12 over x minus 1 all over 6 over x. Now I use these bars simply because I want to remind myself that there's another fraction beneath this fraction. But anyway, from here, we just follow the same paradigm. 12 over x minus 1 times x over 6. We're just using the reciprocal here. Okay? Now, we can use the fundamental properties to look at these and say, well, 12 will reduce by 6 and create a 2 here. This will create 1. So x minus 1 times 1 is x minus 1. And 2 times x is 2x. And there we have our answer. And we can move on to the next one. That would probably scare us senseless. For this class, I don't get very far into the methods that are commonly used that I'll show you in just a minute. We'll do one more example similar to that one just so you can get an idea. There are a couple of ways to do these, and each person is different, and I personally find the way that I'm doing it the easiest way. However, you may find the other method to be of value, and it does have its times where it's going to be more useful than this. So just note that they exist and practice them both, because in the end you always end up with the same answer. So again, I have 24 over t plus 4 all over 6 over t. So this gives me 24 over t plus 4 times t over 6. Now again, the fundamental property tells us that we can reduce these guys. 24 divided by 6 is 4. 6 divided by 6 is 1. And let me go get my pen again. And so we have 4t over t plus 4. Okay, so very simple examples. Now let me show you one with two methods of doing this. These sometimes have a tendency to confuse students. So like I said, just watch and re-watch if needed. But as far as my class is concerned and any homework is concerned, the problems that I will assign will not get any worse than this, because these require a few extra steps and they're extremely crazy in the end. Minus 3 over y. Now, the thing keeps scaring me. It keeps popping on at random times. Now, you'll notice that we don't have just one fraction, but we have two, and also we have an operation in the middle. Well, that just simply means that we need to do a little bit of work. From the previous section, we will simply do our dirty algebra for adding or subtracting fractions, rather. And we will end up with this guy. So now we can see, well, okay. Now we can do 3y plus 3x over xy times xy over 3y minus 3x. Again, our fundamental property states that anything that's going to be on one side after multiplication, we can go ahead and get rid of that so we don't have to deal with it later. So that will then give us, that's not a smiley face, that's an arrow. We have 3y plus 3x over 3y minus 3x. Now, we can factor 3's out of each of these and get this into an even smaller fraction form. So we have 3 times the quantity of y plus x over 3 times the quantity of y minus x. Fundamental property kicks in, again saying, hey look, these guys are gone, leaving us with y plus x over y minus x. Now, the second way of doing these, and let me change colors here drastically to show you, is if we had the same thing, 3 over x plus 3 over y all over 3 over x minus 3 over y, It states that we take these denominators, no matter what they are. If these were similar to, let me find my cursor here, similar to, excuse me, this one, where in the world? Here we go. You know, where we have t minus 4, 24 over t, or I'm sorry, t plus 4, all over, now I'm going downhill again, 6 over t, I'm sorry, my handwriting is, I moved my arm and now everything's off. It would multiply everything, t plus 4, by both denominators. I should change this one into a bracket, leave this one as parentheses. Let me back up here. Oops, too far. There we go. Multiply this, and I'll just change it in here. T plus 4 over, or all over, 6 over t times t times quantity t plus 4. And what this allows us to do is right off do the fundamental properties and say, hey, look, we can get rid of this t and this t plus 4, this t plus 4, leaving us with 24 t over 6t plus 24. I left my t out. How was that? All right. Now, so we can then factor this even more to 24t over 6 times t plus 4. That gives us 4t over t plus 4. I'm sorry about the silence a minute ago. I was thinking ahead and got ahead of myself, and I'm like, wait, my t's going to fall off, and that's not going to be cool. So anyway, we go back down here, and where in the world is, there we are. And basically, we're going to multiply this by the same type of principle, which is going to be x and y over, or all over, I should say, 3 over x minus 3 over y. And this is why I say that this one's just a bit more tedious, but sometimes this one does have its advantages. I'm going to run out of space, so let me go down here underneath. And our first factor is actually going to be, now remember this is xy over xy. Well, let's not say that. Let's not even go there. Let's do, this will be 3y. The x's will cancel. I'll show you this. X plus 3xy over y all over. In the beginning when I said that this would be xy over xy, please disregard that simply because I was thinking of yet another way to do these, which even makes my head hurt to even think about it. 3xy over x minus 3xy over y. Now, this allows us to take our fundamental property and get rid of this x, get rid of this x, get rid of this y, get rid of this y, get rid of this x, get rid of this x, get rid of this y and this y, leaving us with a very interesting, well, let me go back to red here, leaving us with an interesting similarity, 3y plus 3x over 3y minus 3x. Again, as we had done previously, we can factor 3 out. 3 times the quantity of y plus x over 3 times the quantity of y minus x. And the fundamental property again states that, Nathan, you shall not have a marker to write or mark off anything, but yet I found it, so I have succeeded. Mwahaha. Anyway, this answer matches this answer, and that's what's important. And honestly, either way that you find to be easier for you, please do it that way. There are lots of ways to do these. This is just two common methods. I forget the page number that's actually on. Let me look real quick. I think it's 4. I'm in the wrong section. 400 it starts on 457 and goes to 458. Anyway, one more thing that I went over from this chapter is this idea of domain disclusives. And these things are what make what are called discontinuous functions or discontinuous functions. And these are important to understand that sometimes not every answer is going to be every answer. But these are relatively simple and rely on one thing, and that's these denominators. And all you simply do is set these equal to 0. In this case, x plus 1 equals 0 and x minus 1 equals 0. That gives us x equals -1 and x equals 2. And that tells us that our set is going to be x such that x does not equal -1 and x does not equal 2 in the set. And all this seemingly gibberish bunch of writings means is x can never equal -1 or 2, because that will give us 2 in the denominator. Why does that keep popping up? 20 minus. Anyway, that would give us a denominator of 0 if this were -1, and if this were 2, that would also give us 0, which is undefined. It's never undefined does not equal 0. So we leave those out. And what I would ask on a test is, what would be proposed solutions for x that cannot be used in the domain? And simply you would take the denominator and set it equal to 0 in any case. So 1 over 3x plus 1 over 2x equals x over 3. Now we have an x up here, which will tend to throw a lot of people off. Let me draw a little thought cloud around him. This simply means it's in the numerator. We don't care. We can divide stuff. We can divide 0 by things, but we can't divide by 0. So we're going to take this guy and this guy, and we're simply going to set them equal to 0. And how convenient that they both equal 0. So we would have as our solution set x such that x does not equal 0. It'd be all real numbers except for 0. Or, yes, all real numbers. Where in the world is my... There it is. I need to get the glare off my screen. Oh my god. Sorry, that was my phone. I nearly jumped out of my skin, but I do think that I urinated on my leg. Yeah. Anyway, where's my... There it is. So 4x, let's do another one. 4x minus 1 over 2x plus 3 equals 12x minus 25. Hey, look, 1225. That's a holiday, right? 6x minus 2. Okay, now we have a whole bunch of variables and cool things floating around in here. But then again, all we're worried about is one, finding my cursor, and these denominators. That's it. So we'll set each of these equal to 0, and we'll simply solve them. In this case, I'll go ahead and just solve these. I'm fairly certain you can do that. If not, I'll have another video up. This will be 1/3. Okay, so x, our solution set will be x such that x does not equal negative 3/2, and x does not equal 1/3. Again set. My squiggly brace is kind of broken, but it's okay. Outside of these, I'm not worried about you graphing these things for vertical asymptotes and all these horizontal asymptotes and all these other cool things that are later on in other forms of math. But for right now, just know that sometimes you cannot have, where in the world is you cannot have 0 in the denominator, especially in algebra, intermediate algebra. But as far as this is concerned, this is everything that I've gone over up to this point, and the next video will likely be on radicals and complex numbers, which involve the letter I, which you've seen me use a few times in seat, and I'll show you why that's important. But as always, if you have questions, feel free to shoot me an email, or if you see me in class, just ask, no problem. But until next time, I will see everyone later, and have fun.